right, yeah, this is going to be a little bit more technical presentation, but I love that last presentation. I not only have a passion for scouting, I'm an Eagle Scout myself, and obviously I have a passion for bringing more people to the industry as well. So, I'm Brady Haislet. I'm an application engineer at 3M, and prior to that, I was a product developer at the same company working on spray gun development. I'll kick it off just with a joke. I tried to look up a spray gun joke. It was hard to find that, but I did find one. Uh, so, what does a rusty spray can of rust remover smell like? Irony. Yeah. So, anyway, we'll get right into it. We're going to just kick it off with a little history lesson on spray guns. So, we want to just pay some respect to where it all started. So, we can actually credit the initial spray technology or spray painting technology to really two people right at the end of the 1800s. And the first of which is Joseph Binks. You may have heard the name. Definitely, it's a common name now. But similar to that, Nordstrom, if this is a company that was 100 years old as well. So we had Marshall Fields, actually, that he was a department store maintenance manager for. And he wanted to find a faster way to apply his whitewash to all the walls of these stores. So he came up with something very similar to what we have now today as like a garden weed killer sprayer, a container that you have basically a pump and a wand, and you could spray the paint out that way much faster than the brushes they were using at the time. And we can also give credit to someone with the atomization technology that he came out with, and that's Dr. Alan de Vilbis, another name that's very common today, you may have heard. And what he developed was not for the paint industry, it was actually for he's an ear, nose, and throat specialist. And what he developed was a new way to apply these oral medications to his patients' throats. It's very similar to like a perfume bottle where you have that bulb on the back, but similar to like a carburetor, you have this high velocity of air rushing past. There's a tube that goes down into that reservoir, and as that high velocity air rushes past, it creates low pressure, draws that material up, also projects it out in small, fine droplets, and it lands where he wants it to go. So it was the best application method he could find for the oral medication for his patients. All right, so next, let's talk about, that was kind of the origin of just spray technology, but how did that relate to the automotive industry? And at this time, there wasn't really spray painting in the auto industry, even years later into the 1900s, early 1900s. The state-of-the-art solution was the paintbrush, and the only color available was black. So paintbrushes, of course, leave behind a texture, the brush strokes. That's not desirable in the finish. So the application process required a lot of sanding and polishing steps after the application, and with these early varnishes, it was like a 3-week to a month process. So that cycle time was definitely not desirable. There's a lot of room for improvement in that. So in 1915, and this wasn't adopted by everyone, but there were some people that used this flow painting application. It's kind of like an array of squirt guns. So it's a lot better, a lot faster than just using a brush to apply it, but still didn't leave a desirable finish, so that sanding and polishing step was still there. Now, at this same time, in other industries, there were some developments like woodworking, and it was actually the son of Dr. Alan de Vilbis, Thomas de Vilbis, came up with the first handheld spray guns for that industry, but they weren't adopted really until the 1920s in the automotive industry. So here's a patent that was issued in 1928, and around the same time, the varnishes that were being used were replaced with these lacquer paints, and the combination of the spray gun and these lacquer finishes really accelerated those cycle times and left behind a more desirable finish for those cars. So that was monumental in the industry. All right, so let's just talk a little bit about how a spray gun works. What you're looking at here is a spray gun, basically, but we're starting with zero pressure up in the top left corner. So as you go down the columns, you're increasing that pressure. It's very low pressure on the bottom two on the left-hand side. And even at very low pressure, you start to take that stream of, in this case, water, but paint in the industry, and you break it up into smaller droplets and project it away. But at lower pressures, you're going to have a very coarse finish with large droplets. But as you increase that pressure, you're going to drop it, make it into a lot more numerous amount of droplets, but also break it up into finer droplets. And it also takes out more material, similar to that carburetor effect. As you increase that air pressure, you get a little faster application as well. But at a certain point, you can go too fine because ultimately you want to match an OEM finish. So you don't want to have particulate that's so small that the texture is actually finer than the car panels next to the repair that you're trying to match. Also, at this time, if you go to higher pressures, that atomization gets so fine that some of those particulates don't even make it to the panels. There's something called transfer efficiency, which is really simply defined as how much of that paint actually goes where you want it to go. As you think about it, if it gets very, very fine, it doesn't even make it to the panel. It just goes out the booth vents, and that's wasted paint. All right, so we talked about how it works a little bit, but there's also different configurations of spray guns. So I'll just go through this one quickly. One of the earliest ones that you'll see, it's called siphon fed, and the characteristic of this one is you have a reservoir of paint below the atomizing head, and what this requires is a little bit higher pressure because you have to draw that paint up and out. So additional pressure, of course, leads to additional overspray or lower transfer efficiencies. And the one in the center is a lot more common today in our industry. You'll see gravity feed, where now you have this reservoir of coating above the atomizing head. And what that allows you to do is reduce the amount of pressure to still get that same application flow rate that you would want. And lower pressure means a little bit less overspray or better transfer efficiency. And the last one here is just the pressure-fed spray gun. This would be more in industrial applications where you have very large substrates to paint, but you still need that good finish and keeping a wet edge in the application. So you would have pumps or some sort of a pressure pot to apply very large amounts of coating. Next, we'll talk about the different regulatory components for spray guns. And as we talked about the early 1900s, when spray guns first came online, they were kind of the wild, wild west. There's no real regulatory body they needed to adhere to for air emissions. So we call that now conventional. But in the 1980s, there was a regulatory push to improve that transfer efficiency and reduce the volatile organic compound emissions of spray guns. So they came out with something called HVLP. HVLP just requires that a spray gun has 10 psi or less under the air cap, and they assume it's about 65% transfer efficiency when you do that. The next push was in the early 2000s. There was kind of a compromise made between those regulatory bodies and the industry, and they came up with a way to ensure that you have 65% transfer efficiency, but you don't have that limit of 10 psi under the air cap. So this allows you to maybe get a little bit finer applications or faster applications than HVLP, depending on the design of those spray guns in the early 2000s. So that's called compliant. All along this process, there were subtle improvements in usability, spray performance, maintenance, ergonomics, all sorts of other things. Obviously, this is century-old technology, so a lot of things have improved along the way. Now, the most important feature of a spray gun, though, is just how it sprays, the spray performance. And there's some very obvious attributes there. You've got the size of the pattern, the distribution, and the balance. You wouldn't want a pattern that's too center heavy, top heavy, bottom heavy, splitting on you or anything like that. But as we talk about atomization, I'm going to just hone in on that one specifically because atomization directly relates to the material efficiency. And material efficiency relates directly to the bottom line of a body shop. So it's important to have enough atomization to best match those OEM finishes. But if you're over-atomizing coating, that results in wasted paint. That's going to make your efficiency suffer. All right, so quickly I'll just go through the one area that 3M has in this space. And recently we launched the Performance Spray Gun in 2020. And it offers some new technology with replaceable atomizing heads. The idea here is just to really take the pain out of painting for our customers. We want them to be able to maintain the equipment really easy. Changeovers are faster. But we can say it's the lightest spray gun in the world as well. So we wanted to work on those ergonomics. And it's also industry leading for transfer efficiency. So we've been able to help a lot of shops by even as these paint costs are rising, people who have been adopting this spray gun have been finding they've been able to reduce their paint spend. So definitely something we've been happy to introduce for our customers. We've expanded this. We're going to continue to build on it. So we added some additional tip sizes for our HVLP offering, and we now have compliant nozzles that are available in Europe, but it'll be a little bit before they come here to the US. It'll be about 2024. And lastly, for versatility, if you have any texture coatings like a rocker guard or an undercoating, we do have an accessory. It's called the HO, or high output conversion accessory. And this is really neat because it allows you to take pressure on the outside of your PPS liner and deliver good flow rates with something of a very high viscosity. Well, you still have all the control of a spray gun, which is really nice, and it allows you to really control that application texture and better match OEM for those coatings as well. So, what does the future hold for spray guns? Of course, we're always looking to stay up with the times. As new coatings come out on the market, we want to make sure we have optimized application properties for those new coatings. We also want to continue to work on that transfer efficiency. And you can do that by, as you saw, those particle sizes are really a normal distribution bell curve. If you can kind of shrink that down and cut off the tails, you don't want the higher texture droplets and you don't want the finer droplets that never make it to the panel. So anything you can do to kind of tighten that up is one thing we can do to offer some additional transfer efficiency for the customers. And one it's not as expensive as the paint, but there is still energy cost in air consumption. So anything you can do to reduce the air pressure required, or the CFM required, I should say, for a spray application is going to reduce the energy cost for the shop as well. And lastly, just like the century of development in spray guns, we're going to continue to find ways to make it easier, more simple to use. Anyone new in the industry, we want to make something that's really easy to pick up and use day after day without much pain. I'm just going to leave you with a couple tips before I take off here. So definitely spend time to maintain your spray equipment. Make sure your painters are doing that, because if you have a spray gun that's not spraying like new, that results in basically wasted paint, which means wasted money. So take the time to rebuild or replace spray guns that aren't spraying like new. And also take the time to optimize your applications. A lot of people want to leave that show car finish with as fine a finish as possible, but really you want to match that OEM. So find that minimum pressure that allows you to still get that OEM texture on your application with the coating you're using, because any additional pressure is over-atomizing coating, and that results in wasted paint on any spray gun. Doesn't matter what you're using there. That's all I had today, guys, so thank you very much, and yeah, talk to you soon.